Do you like hands-on projects where math and science make sense? The engineering and design sector follows the nationally recognized Project Lead the Way curriculum. The sector is designed to let you explore architectural engineering, computer engineering, network project design, and environmental science. Internships in this program may occur in engineering firms, architectural firms, and construction sites.
The engineering and design industry sector provides a strong foundation for students in California. The demand for engineers in a variety of specializations throughout the state and the nation will remain high. In San Diego, many firms cannot find enough qualified engineers locally and need to hire from outside the area. Jobs are varied and diverse, ranging from architectural and structural engineering, computer and networking engineering, to environmental and natural science engineering. Salaries in this growing field are consistently higher than other professions.
What are you basing on?
Generally, what we like to do at UDEC is related to water and wastewater engineering. And the simplest way to describe it is that we help people move water from one place to another, whether that be from a creek or a stream or from any water source, a pond or a lake, through a treatment process and then down through a distribution system to those houses. At the same time, taking it from the houses through the wastewater system back through pipelines to a collection system for treatment and disposal. So it's the whole water system from the original source to people's houses or to businesses, and then out of those businesses back into the collection system and to dispose it. Well, when I was in high school, I did pretty well in math and sciences anyway. I mean, there's a personality with engineering. You tend to like to fix things, to solve problems. There's an existing pipeline that's along the lagoon in North Agua Hedionda Lagoon. This is kind of how it looks. You've got the lagoon sitting here, and you've got the slope of the ground that comes down into the lagoon. And what's happened is that the tidal action of the lagoon has actually eroded away the slope of this hillside, so now it's more like this. And the water actually stands all the way over to here. So this is the water level. Now you got a situation where you got a pipeline that's essentially underwater, and there's no way to maintain that pipeline. And one of the options we came up with over the last couple of years is a way of moving the pipeline away from the shoreline by using a method called microtunneling. Engineering it has been around for thousands of years. You don't need to have to learn everything. You just need to stick with it. The math and the sciences are not that difficult to get through. It just takes time. The real thing that people look for in getting out of college is people that can take on a challenge and get through it. People don't tend to hire quitters, I guess you could say. You don't need to actually get straight A's through your whole career. What you need to do is get through the process. Somebody that can follow through with tasks, follow through with projects, do their homework and get it done, are the kind of people that really succeed in any kind of industry. And that's the kind of people that people are looking for is the people that follow through and do what they say they're going to do. And don't give up. As long as you don't give up and keep on working, you'll be successful in almost anything you do.
As a senior designer, I support the engineers in creating design drawings. We work as a team here. We might work with 7, 8 different people on a single project. So it's really important to be able to get along with the other team members and to work well with others. You're not just stuck in a cave just doing CAD work all by yourself. There's a lot of interaction. We had this story too. It was different. I took any drafting class that they had available in high school. So I took all the architectural drafting. They had a little bit of civil kind of stuff where you learn how to create contours for topography. They did a little bit of electrical, some mechanical. A lot of mechanical in high school. We were doing a lot more mechanical drafting, which were parts and things like that. So you learn how to do schematic drawings, isometric views, three-dimensional kind of stuff. I started here as a gopher, just delivering plans and go to the city, get drawings here and there, drop these plans off, pick stuff up. Then I just slowly progressed over the years and became a designer, learning civil applications. Then I picked up another application on my own, 3D Studio Max, for doing 3D visualizations, mostly for architectural and terrain modeling and things like that.
So yeah, one of the neatest things about engineering is seeing what you've created on paper actually getting built out in the field. So going from the kind of mundane calculations to creating a drawing to actually in the field there with major equipment moving and placing large concrete structures and laying pipe. That's really the neat part of the engineering field, I think, at least for a civil engineer.
We manufacture underwater robotics. This is a device that doesn't care how deep it goes, it doesn't have any decompression requirements, it doesn't care how cold it is.
Now we're going to submerge it and just cruise down.
It just goes and operates and does things so that it's much safer. We've got production engineering. In there, there's an electronics engineer, a mechanical designer, and another electrical engineer that does manufacturing engineering. So how to get it together in the, in all the steps of putting things together. We're actually a design, assembly, and testing house. So which means that we'll design a part. Typically we use something like SolidWorks, so we solid model a part. We'll then rapid prototype that part, making the parts on a computer at a service bureau, bring them together, and then we'll test it, validate that it works the way we hoped it would, and we'll have injection molded tooling, for instance, made that will produce these parts then in the material that we specify. So we really cover all of the disciplines that you'd have at Boeing. And we have to do that in a very compact unit. We have 66 employees here. So there's a lot of people that wear a lot of hats.
This is a special attachment that goes on a remotely operated vehicle. It uses what's called a vortex generator. This device spins, rolls the water in this skirt like a donut shape. The water rolling into the donut hole is a low pressure zone, and that creates vacuum. This is a great example of one of our 4-thruster LBVs. This one's rated to 150 meters. If you look at the bottom, you can see the 4 thrusters. There's 2 horizontal, there's 1 vertical that passes through the vehicle, and there's a lateral that lets you fly sideways. So adding the lateral gives us that sideways flight. So if I come up to the side of a dam, for example, I can then fly this way and keep my cameras and sonars on the target. Okay? It also allows me, a lateral thruster, if I had my grabber extended and I was a police department, maybe gathering evidence that someone had thrown off of a bridge from a crime. Very common application. If I want to get down there and get that gun, I can come around using the lateral thruster and turning, and I can get right to the trigger point, the grab point maybe on that gun. Okay? So that's one of the beauties of having a 4-thruster ROV.
We're part of the Marine Technical Society, and we get interns from high schools and colleges. We look for hands-on skills, as well as education. If they show an interest in robotics, maybe the FIRST Robotics or the ROV competitions, or they've worked on cars or bicycles, done something with their hands. So connecting the two from an engineering point of view.
In order for our architecture to continue through and become an actual project, we have to hire engineers, not just one, almost 5 or 6 engineers to help put this project together. We're talking about civil engineering, structural engineering, electrical, mechanical, plumbing, and we don't separate these things, which that's what makes architecture so great as it relates to engineering, because they have to tell us whether this building can be built and what size of beams, what kind of structures, and they can be just as creative. So at the design end, we have to incorporate all their ideas. As a team, we all sit at this table and we get together, we just sketch out ideas and say, hey, can this work? They say no. They have ideas, we say no. And you know, we could be fighting, but at the end of it, it's one big group hug at the end, and we're all excited about taking this project all the way for the next year and a half. So engineering is an important part of what we do as a whole, as a team, and it has to work together. No one piece of that team, that engineering team, can falter from it. This is a rendering model that you see that's been actually created in SketchUp and then rendered in another program. And this helps actually, just like a physical model, and it helps us describe to the client or to the community the feel of the design that we have. And putting texture and color to it helps the client out get a feel for what the design is about. Usually when you enter an office, any architecture office, this is no different than any other ones, we either take an intern, someone that's in school, and we introduce them to the office and the different kinds of levels that we have. And usually that entry-level person will go in and they'll touch a lot of the parts of what we do at an elementary level, just to get them used to the idea of what an architecture firm is about. And from there, usually someone with an architecture background, usually with an architecture college background, we hire them at another level, which they start to begin to draft for us. That's where you learn most about architecture. That's when you start to realize, as you're drawing this day in, day out, you're starting to realize how a building actually comes together. Right? It's not just a bunch of lines that you put either hand-drawn or on the screen. Right? This is when you start to understand the nuts and bolts about how something comes together. All right? And you work at it as a group, not just a single person. So by the time I hit 8th grade, I wanted to be in architecture, without a doubt. That's what I wanted to do. So I wanted to do whatever it took, whether it was within school or out of school, do everything that was related to architecture, whatever it took me to get in. You don't have to be the expert. You don't have to be the valedictorian in physics or science or drawing or whatever it is. You know, do whatever it is that entices you about architecture. If you sketch, sketch. If you like to draft, draft. So I did that, and I chose an architecture school, Cal Poly, and went about my avenue, and that enforced the things that I learned in high school, that there were many avenues, and Cal Poly was going to do this for me and have me experience all these different avenues.
Jobs in the engineering and design industry include CAD technician, environmental sampling technician, architect, computer engineer, telecommunications technician, industrial engineer, environmental engineer, hazardous material remover,